So now for this one, I want to show you how you place the ACL. So remember that when we do ACL, there is always two steps. Always two steps. You must do it systematically lah. So step one is always we create the ACL rules. Now this is where we put in who you want to allow, who you don't want to allow. So this is where you have all the permit and all the deny statement here. Okay. After you've done this, you must remember that okay. You have to place why cannot write? Place the ACL on router interface. So step 2 is like after you have the rule already, you need to decide where you want this rule to take place. Because a router is like that one. Router got so many interfaces. Let's say I got one example. This is a 4 interface router. Now, if I created a rule called ACL1, so let's say this is ACL1. This contain one, all the things that you say. You can do this, you cannot do that, who can do this, who cannot do that, all these rules. But it doesn't really work until you go and find one of the interface here and put it. So now the next step, part 2, is we have to decide whether should I put it here, or here, or here, or here. Now there is a way for you to find where is the best place to put it. So remember I said before, placing this ACL is an art. Like how much you understand about network will actually make you decide where you want to put it. So one thing you should know is, if you place in the right place, your ACL will work. But there can be a better place. For example, if your friend is, he is a bit smarter because maybe he take Datacom 3 trimester already, this is his 3rd time, now he knows where to put it. Then the router may be a bit faster compared to if you put it in other place. Later I will tell you why lah. Okay, so now this is all in step 2. Today I want to teach you this one for placing the ACL. Now, on the slide, this is the slide that you should be referring to, this one. Okay? Before that, I give you one example. Imagine now I got a router. This is a 2 interface router only. Now, I created one ACL1 already. This is a standard ACL because from 1, you know this is standard ACL. Now, we don't bother about what is inside the ACL1. Just imagine you have one ACL1. Now, in this router, I got 2 interfaces, FA00, FA01. Let's say like that, okay? So when we want to put this ACL here, we actually got 4 options. So first thing you must know is, every interface on the router, there is 2 directions, in and out. So ACL, they actually care about the directionality. Whether you are going into the router or you are coming out from the router, it makes a difference. So for example here, this is FA00. That means when I want to place this one, I got the first option is in, the second option is out. So I can write like that, FA00 in, FA00 out. So the in direction means that the packet going inside the router. So the arrow is like that, means that the data come from outside go into this router. If FA00 out, means that the data can come from somewhere here and then try to get out like that. So the direction is like that. FA00 out means that you are going out from the router. So you see, in one FA00 itself, I can put 2 places already. I can either choose to put this ACL1 here, FA00 in, or I can put it here, FA00 in and or FA00 out also can. Now there's no right or wrong, there's just whether which is better. Okay. Now the next one, you can look at the other side, we have another interface. This one is called FA01. So same thing, every interface you have 2 directions. So the first direction is you can have a data that go out from the router. You have one more that is going into the router. So this one here, the one on top will be FA01 out, because the data is going from inside the router, go out from the router, right? So here we have another one. This is called FA01 because this is a 01 interface. Now you see the direction is the data is going inside the router, so this is in. Now that means in this simple router with only two interfaces, if I want to say ACL1 want to put where, I can choose either from these four. Understand? Okay, now that's the first thing. Now of course, if you have a router with more interfaces, then you have more place for you to choose where you want to put it. Okay, then we can come back to your slide. Now what I just draw for you is exactly this example. Okay, so this is how you get all these number on the router, because every interface got two directions, one in, one out, like that. Right, so now that you understand the concept, let's look at the command. When we want to put the ACL on either one of these interfaces, we first have to go into the interface that you want. For example, if I today decided I have this ACL1, okay, I think this is called ACL10, right? Okay, I have two ACL, one more is called ACL12. I want to place them, okay? If the question says the ACL10, put it in this FA00, in this direction, go into the router. This one here, ACL12, put it in this direction, going out from the router. So if you look at the command, it will be like that. First, we must go into the interface first. If I want to put it in FA00, I need to go to int FA00 first. So if I want to put it in FA01, then I later need to put int FA01 here. You choose the interface that you want to put your ACL. Then the command is very simple. See, is IP access group. So the keyword, the syntax here is access group, followed by the ID of your ACL. So if you want to put ACL 10, here I will write 10. Understand or not? And then the last parameter is the direction, in or out. So you see the command is so short. Only IP followed by access group, followed by your ACL number. Last one is the direction. So the first example, if I want to put ACL 10 here, over here, in FA00, in the at the direction going in the router, I just here you see I write 10 in, like that only. So the command is not hard. Honestly, if you understand, it's not hard. Like, okay, you see for this one, ACL 12, the command will be access group 12, and then because this is the out direction, here I write out, like that only. Command is short and simple. Now, short and simple doesn't mean it's easy, because first, before that, you must know where to put. That is the hard part. The command part is not the hard part. Understand or not? Okay. Right, so this is the directionality. Okay, then we go to this slide. Just a bit of thing that you should know. Okay, you see, based on this slide, he said there are a few things that we must follow when we do ACL. Now, I haven't tried. If you don't follow, I don't know what will happen, but I always follow. Okay, so first thing is, the same access list that we created, you can put it at different interface. That is number one. Number two is, only two access lists at the same interface for both in and out. Okay, now the third one here is not important, because, previously, when you are still a kid, small running around, the internet is a bit different. We have a few protocols. Last time it's not just IP. Now today when we talk about networking, talk about datacom, what you dream at night when you think about datacom? IP address. So right now, IP, because there's only IP. Everyone is using IP now. But back then, there are more than IP. You have things like IPX. So you see, now if I use Apple or I use a Windows PC, we all have IP address. So, right, so that we can ping each other, we can talk. Last time it's not like that. If I use Apple, I don't use IP, I use IPX. They have their own protocol. That's why you see number 3 here, you have IPX access group or something. But that is not important anymore, because now they know people use IPX anymore. Everyone is using IP. Maybe Steve Jobs on top, he used IPX, I don't know. But no more people use here, okay? That's why this one is not important. You can just cancel this thing, this one only. Okay, you just understand the first two. Right. Now I give you the example using this one. Okay, now let's say I got ACL 1 and ACL 2. Okay, rule number 1 say this ACL okay, I can put it here. Then if I want to put it one more time, like here, this one is correct, this is can. Means that the same ACL that we created, we can repeatedly put it in different interface on the router. Why? It's because you create one, this is your rule. How many times you want to use it, where you want to use it, is up to you. Understand? So I can actually put the same rules, the same ACL one, in many of the interface here. Like that is correct one. As many times as you like. But of course, you must think, if I do this, what is the implication? Are you trying to mess with your router or what? This one, your router will hate you, you don't do like that. But you can do it. So that is rule number 1. Now rule number 2 says that, let's say I got two ACL like that, ACL 1 and 2. If I put one ACL 1 here in FA00 in, I cannot put another ACL in the same interface FA00 in anymore, because at one time on each interface, what the direction each direction only one ACL can be there active at one time. You cannot have ACL 1 and ACL 2. Then should I follow ACL 1 or ACL 2, or should I follow both? Right? So you cannot do that. Okay, so that is what the slide is trying to tell us. Right, then we go back to the slide and then we see the next one. Okay, now I want to teach you about one more example on whitelist and blacklist. This may be very easy for you, but just in case you didn't know, I think better I tell you this one is, if I remember correctly, is in the lab test. Okay, now for the next example class, I need you to open the latest slide that I uploaded on Sunday. There is another extra slide here. Yeah, you go and then you try to see the last few slides. Go to the last few slides. There is some hidden slide there that is supposed to be for standard ACL, right? Okay, now we want to do this example today. Okay, if you didn't notice that we have another new slide, maybe I didn't put the word big enough. Alright, this one, I need you to make sure you can understand this example. Then after that, I'm very sure you can pass datacom. If you can understand this example, you can pass datacom. That is my guarantee to you. Okay, if you cannot pass, come back and find me, money back. But if you want to get A, later got one more example here. So this example, if you can do this example, then you can get A. Different one, see how much you want. Every people want different thing one. Okay, I say like that, later halfway during the break, no people come back already. You guys just want to pass. Okay, so you see this example, very simple network. We have PC0, PC1 and PC2. And we are going to use standard ACL now, standard ACL. Okay, let's understand what we have first. Right now, I got this router. You see this network here? I got 3 routers actually. Router 0, 1 and 2. And I got 2 PC here, PC0 and PC1. I have PC2 here. Okay. Now, I am actually supposed to do something to control the traffic between these two computers, PC1, 0 and 1, to PC2. Okay. Now, if I want to control traffic, for example, this kind of situation, I have 3 routers, right or not? Do you think, first question is, we know that if you want to control, do ACL to control traffic, we do it on a router, right? So here got 3 routers. First question you should think is already, which router is the best? Okay, now in the exam, if you panic, you just do in any router that you can configure. That one means that is the right router. But the right way is you have to think first whether you want to do a standard ACL or extended ACL. Okay. Now, in the case of standard ACL, the best router to do is here, router 2. In this example, okay. Now, I must make this clear. If I want to control these 2 PC, so I'm like the admin for this network, then when you want to do standard ACL, you do it here. Okay. Now, if you want to do an extended ACL, which I'll show you later also, you do it here, closest to you. Understand? Okay. Now, if you don't understand why, it's okay, because I don't have time to explain why. Right. So today I want to teach you how to do this rule. Okay. Now you look at here, this corner here. This is exactly what we need to do now, right? So we have this PC0. We want to block this PC0. And then we want to allow the PC1. Okay, so this is what we have. Okay, you see, now we got 2 things to do. The first one is to block PC0 to PC2. The second one is allow PC1 to PC2. Okay, so meaning that you try to follow me, because if you lost halfway, it's very hard. This PC0, we don't want him to be able to ping this guy. Meanwhile, the other case, I have one more PC1. This one must able to ping. This is what we want to do. First, we understand the situation first, right? Now, if both also no need to ping, you don't have to do ACL. Just pull the cable, then that's it, right? But now, because one can ping, one cannot ping, so we have to set ACL. Now, for today's example, I will do the ACL here. Okay? I called it ACL1 later here. Right. So, the next thing you must know is there is 2 ways to do it. Like I said before, again, there is no right or wrong. You can either use a blacklist or a whitelist, depending on which one you like. Like you can like MACD, you can like Coke. It's just different. Okay, so now I will show you both ways, and then you can decide for yourself which one is you like it more. Okay, we do a blacklist first. The first example is, I will show you how to do a blacklist. Now the answer is already given to you here. I will just show you how I derive this answer. Okay, now in blacklist, the idea is that we must first know who I want to block. Meanwhile, in whitelist is the opposite. Means that I must first know who I want to allow, right? So in this case, blacklist and whitelist are both okay, because I have one guy to block, one guy to allow, right? So it's actually there's no difference here, whether you do a blacklist or a whitelist. Now for the example of blacklist, if you want to do a blacklisting, you must know that who you want to block. This guy, I want to block. His IP address is 192.168.1.10. Okay, so this is the guy that I need to block. Meanwhile, this guy here, 192.168.1.1, this one we don't block. So in blacklist, the idea is, okay, I write the command for you. We are doing step 1, which is now we will create the rule first. Then later only I show you the placement. Right, so the command is access list. Now I use 1 because this is a standard one, so I just use 1. Now blacklist, blacklist means that you want to block people, so you will use the keyword deny. Okay, followed by only one more syntax, which is the source IP. Who do you want to block? In this case, who we want to block? We want to block this guy, 192.168.1.10. Right now, this is the guy. I know it already for sure. So here I will write 192.168.1.10, which is the IP address of PC 0 actually, right? Now remember that because this is a type A, here we got 3 types, one host, one network, or you can use a wildcard mask, right or not, or the any keyword. So this is case 1, so you must remember to add the keyword host for one specific IP. Must remember to add host, and that is the answer already. With this one line of command, we already block this guy. He will not be able to communicate later, right? So we have done the first part only, because remember we have still got one more computer to take care. This guy, which is to allowed. Now, when you do a blacklist, the next step is necessary, okay? It's important, because if you don't do it, it's like you do it halfway only, okay? So the reason is because that is, every time we do an ACL, the router will automatically add this statement at the end of your ACL, which is deny any. Now this statement you don't write because you're not supposed to type this, okay? I just show you the second line is because you must know that this is called a hidden statement, where the router automatically add this, even you don't type it. You don't have to type it actually. It's already there by default, okay? So what it means is that this is hidden. You may not see it, even though if you type show access list on the router, it may not appear, but it is there. And it also means that all the computer will be blocked, because it says deny any. Understand or not? Means that router is very 保守 means that he will not simply allow anything to go through. So even though now I say already, I want to block 192.168.1.10, which is what we want actually, but the router actually block every other IP. So let's say if you are 1.1, 1.2, 1.3, 1.4, all will be blocked, because the router have this access list one deny any statement, which is hidden and automatically added by the end of all access lists you create. You understand or not? So this one we cannot control because it's already there. Okay, so what it means is that with this one line of command, this guy will be blocked. Even if I add one more computer here, 192.168.1.3, he will also be blocked. You understand or not? This is how ACL works actually. Now, which can be good or bad lah. Good is that one day if a new PC connect to the network and he happen to be an attacker, he will be blocked. Good lor. One day the new PC connected is a president. Prof, you come visit FICT and he get blocked. That one not so good lah. Maybe next week I don't come here already. Okay, so it depends really. So now because of this situation here, we still have one more thing to do, which is we want to make sure that this PC is allowed. That's why we have another statement to write. Now, this one, remember, this is not, you don't write this thing one, it's already there one. So what we need to write is this. Another statement to allow PC1. So I use access list 1. In this case, is allowed, so I use permit. Then followed by the IP address of the PC I want to permit. In this case, is 192.168.1.1, PC1. So here I write 192.168.1.1. Remember, because this is a one machine, so we add the host keyword in front, and that will work. That means with these two commands, we already achieved what you want. The first one is to block PC0, which is done with the first statement. The second one is to allow PC1, which is also done in the second statement. Understand? This one is quite simple. This is like the simplest example I can ever give you. Okay, right. So 2 lines to do 2 things. Okay, now the answer that you already copied is correct, so you don't erase. I want to tell you that there is one more way you can write this, which is for the last part. So if you want to write this answer as well, you can write one more time. Don't erase this because this is correct one, okay? Now, specifically this line here, if you don't want to write the full one, you can actually write in this way. Access list 1 permit. Now here, instead of I put in the host 192.168.1.1, which is for PC1, you can just use the keyword any. Which means that now, if I have this line here, any computer will be allowed. Because I permit any, means anyone, except 192.168.1.0, which is in line 1. Understand or not? So, if you do this way, also got good or bad. Now, means that if I do permit any now, let me think. Right. So, in the future, if you add a computer, so let's say if I add a computer, and this one is 192.168.1.3. Okay, let's say Now, with the third statement here, you actually allow this guy to go through. Understand? So it's kind of like future-proofing your network. Understand? So rather than if I add a new computer, I will have to come back and then add one more IP. Why not we just do permit any? Meaning that if you are not blocked in the blacklist, everyone else will be allowed, which is actually a very good way to do it. Understand? Okay? So of course, if you already write this statement here, you don't have to write this one. It's redundant. So among this and this, you choose one only. Okay? Now, there is one more very important thing that I want to point out here, which is the router, you see, the router that we have, they are very systematic one. When we design the ACL rules like that, this one very simple because I only got 2 lines. But in the real ACL, it can be 10 lines or 20 lines or even more, right? Now, when the router read what you design, they will read line by line, starting from the one on the very top. So it will first read this line, and then he read this line, and then he read this line, depending on how many lines you have, of course. Now, means that when we design ACL, we cannot add a new rule somewhere in between. Okay, now for example, if I already have something like this. Okay, wait now. Okay, let's say I got something like this. This is the answer to this question. Correct or not? This is correct one. 2 lines can achieve what we want already. But if I now write one more statement like access list 1, deny, host, 192.168.1.3. Let's say I suddenly add this line. Now you must know that the router will not block this new computer, because the router always do line by line. So if in the second line you already say allow everyone, in the third line you cannot say you go and block. Then also you can see what you want. You just say this okay, then that okay. Like when your girlfriend is mad, you say go lah, you go lah. Do you really go when your girlfriend say you go lah? No, that's a trap. Don't go. So this is like that. Now means that if you write ACL, you cannot suddenly tell the router block this, that one. Like in this example, if I already tell the router, you allow everyone, you cannot suddenly add one more line, hey, you go and block this guy. If you ever want to do that, there's only one way. You have to redo all the ACL all over again. You cannot suddenly just insert one line here. Understand or not? Okay. Okay, now that is this example here. So I will erase this one because this is not the answer. So this is the answer. Okay. Now what you see here is the blacklist approach. Let's look at if we can do this with whitelist, or maybe it's even faster or better. So the same way here, the same situation here, but we want to block PC0 and then we allow this PC1. Okay. Now in the whitelist approach, we have to first decide who I want to allow, because any one IP address who is in the whitelist will later be allowed. If you are not inside, then you will be blocked by default. Okay, so starting with the first command, access list 1, because this is a whitelist, so we start with permit. See who you want to allow. Okay, now in this case, we want to allow this guy. That means the IP that we allow now is 192.168.1.1. Okay, so I come here and then I write 192.168.1.1. Remember, add a host keyword in front. That is the first line. With this line, I already allowed PC1. Of course, one computer only. Right or not? Okay. Now, do you think this is done already? Means that if you are 1.1, you'll be allowed. Do you think that's it? Or do we have to do more command? Yes or no? Yes or no? You tell me. Yes, done already. Or need more command? Need one more command? One more command. You think done already? Yes, you are right, done already. Everything you don't know, just ask David. You can start your own show, ask David. Okay, that is correct, it's done already. Okay? Now, you see why? Because right now, normally what we will do is, after you've done the first line, you still have this to do, which is to block PC0. So you will write something like this, access list 1. Then you deny. Okay? Followed by PC0, because now we are going to block PC0. 192.168.1.10. PC0 is having 1.10, and then you add the host here. Like that. So these two commands will do exactly what we want. Right or not? The first one, we will now allow PC1. The second line will block PC0. Done. Boss is very happy. I hired the right people. Okay. Now you have to also think, this is right. If you write this in the exam, we'll give you full mark, don't worry. But I just want to show you that there is a better way. In case one day you want to work in Huawei, then you must follow the better way. So here, you see, remember I say that every time you finish the ACL, the router will automatically add this statement, which is access list, access list 1 deny any. Like that. This is added by default. So meaning that every time you write any ACL, there is always this line here at the last one, which is hidden from you, but it's actually there. So you see, what does the last line do? He say that I will block anyone else. So if you look at this one here, if I start from the first line, the router will now know if you are 1.1, which is PC1, right? I will allow you. If you are 1.10, I will block you. The last line, if you are any IP, like 1.2, 1.3, 1.4, all I will block. Right or not? So if you really think about this, in fact, this statement is now redundant because the last line will also somehow block PC0. Right or not? So even if you don't write the second line, the last line is already going to help you block PC0, not just PC0, in fact, anyone else, because it's a whitelist. So if it is a whitelist, if your IP is not here, you will be blocked already. There's no need for you to just go and tell the router, go and block this guy, that guy, because he will be blocked by default anyway, right? So in this case, you do not really have to write this line because it will work. Now, of course, this line you don't write because this line is by default, it's already there. That is why the answer is just one line, like that. So, in fact, if you do whitelist, this is a better way because you only need one command rather than two commands that you see when we do the blacklist earlier. Understand or not? Like that better. Right, okay. Now we have done with the example on step 1. So now you see that whitelist or blacklist, there's no right or wrong. It's really which one you like more. Okay. Now the next example before we go on a short break is now we want to go to step 2 of the ACL. Okay, now we want to place it. We want to put it in some of these routers so that it works. Okay? Now, for this example, I'll be using the whitelist ACL. Now, this one doesn't matter. If you use whitelist or use blacklist earlier, the placement is the same. Where you want to put it is the same. Right, so let's look at this ACL example. I color this a bit nicer. Okay. So let's say now we created ACL 1. Just now from the previous 2 examples, we have ACL that is already able to block PC0 and allow PC1, right? Now in this case, to put this ACL, where do you think we should put it? Of course, like I say, you have 3 routers here. Depending on whether you are doing a standard or extended, there are different better way. But to simplify this example, I will just put this in router 0. Okay or not? Okay, but you must know that it may not be the best one. I just want to teach you the concept. Okay, then the next one, in the router 0 here, got 2 interfaces. The next thing we choose is, should I put it here or here, like that? Okay, now if you decided already, zoom in further, see how big it can zoom. If I decided already FA00, the next thing to decide is, should I put it in or out? So this is the last thing we need to decide. Okay, so step by step we do. Right, so let's say we look at FA00 first. Guys, we look at FA00 first. Now, remember one rule before we start. This is very important. The standard ACL only check for source IP. Okay, means that the standard ACL do not care about destination IP. He don't care about where you want to go. This is very important concept. So when we do standard ACL, when we ask the router to check whether this packet is allowed or this packet is not allowed, the router will only check the source IP, means that who is the sender. That means if you write a blacklist to block people, like block PC0, the router will now check, okay, now this packet, is it coming from PC0? If it's from PC0, I cannot send it, I must block, because the ACL says so, right or not? Then if the data come from PC1, okay, this one is allowed. So the router only see who is the sender. I don't care this packet is going to PC2 or PC3 or PC4, which is not even in this network. I only care about who is the sender. This one can understand. Okay, this is very important concept. Right, because of this, when we do the ACL, right, the rule here I don't write already. The rule in ACL 1 is the one that you get from previous 2 slides, okay, where we have 2 command or 1 command. All right, so first, to put this ACL in here, this FA00, there is 2 ways. The first way is in direction, so it means that this is going into the router. Then there is another way. This is going out from the router. Okay, so now we have to decide, in this FA00, should we put in the in direction or out direction? So you see, this one is called in, because it's going inside to the router, right or not? This one is called out, because it's coming out from router 0. The in and out, you must make it clear first. This one understand all the direction, can see. Okay, so now, should we put it in FA00 in or out? You must see how the packet go. Okay, now if I use a PC0 here, PC0, I send a data. I want to send this data to PC2, right or not? I send to PC2. So the data will go like that, and then finally it arrives at PC2. So this time is a bit different, because we have ACL. Means that the router must now check whether I can send or I cannot send. So when the data come to here, you see how it go. It flow from here, he go to this router. This data here is going inside, right? Not going inside. That means when we want to place the ACL, we have to choose in, not out, because the data is going inside. So it means that as the data go inside this router, we must already check, is this allowed or not allowed? ACL 1 say this is not allowed, right? Because we block PC0. So this data, as it go inside this router 0, we must check already. And then after checking, we know that this is blocked, so I will throw this away. Okay, I hide this somewhere you cannot see. Understand or not? So same thing, if I have a data from PC, let's say PC1, okay, when the data come here, as it goes inside this router 0, we must check already, yes or no, right or not? So ACL1 say what? Yes, PC1 is okay, then you can go through. Understand? Then you will continue. So you see the data is like that. As soon as it enter the router through FA00, we are already checking yes or no, right? That's why we must use this direction. This is correct. You cannot put out, because if you put out, okay, you see, if I put it here, this is correct. Now imagine what happened if I put in the out. So if I put it here, okay, now let's say if I erase this, okay, the data come here. Wait, let me erase the whole thing. Now if I put it like that, it's out. It come here. When it goes into this router, your ACL1 will not be used. It will not check anything because you say out. Out means that if the data come from here and then go in here, exit from router FA00, then it will check. You understand? So this is the difference between the in and the out. If I put in, it means that when the packet enter inside FA00, I check. If I put out, AC1, ACL1 out, means that when the packet go inside the router, as it go out from FA00, then I check. Right or not? Understand until here? Can? So out is not correct. Understand? Now let me explain further, finish first, then only explain why. Okay, so now you know this is the correct answer. If I want to do ACL1 in FA00, it must be in, not out. Okay? Now the other answer is you can actually put it here. It's also correct. For example, if I decided to put it here, let me draw this again. Like this. So this is FA01. This is FA01. I have one FA01 go inside the router. So this is in. Then I have another FA01 that is going out from the router. So this one, I call this out. So I got 2. In this case, I got 2. Understand or not? So here we also need to choose one. Now, so you think this one, should I choose in or out? In or out? You must see how the packet flow. Okay, now you see, if I have a data now, imagine this is the data going from PC0, 1 to go to PC2. Okay, like that. Come, you see. The data go into this switch, go to router 0. Okay, so I go in already. Let's say this one is not here. I delete this one. Now, as soon as it want to exit the router, so now he's here. I want to get out. So I exit from FA01. See again, come in FA00, go out from FA01. So means that the ACL that we put must be this one. Out. We ask the router to check when the packet exit from your FA01, not coming inside your FA01. Understand or not? You must follow the flow of the packet. So again, the reason is because the data will come here, go into this router through FA00. That's why just now we say this one must be in. Then when you want to exit, he will exit from FA01, go out from the router. So this one is out, is correct. That means if you want to put it here, you must put at FA01 out. Understand or not? Okay, so the final answer is, you can see here, I have 2 options. If I want to put in FA00, it will be IP access group. So I go to INT FA00 IP access group 1 in. If I want to do it in INT FA01, also can. But now the direction you must be careful, like IP access group 1 here, this is out. So either one is correct. But if you do FA00, must put the in. If you do it FA01, you must put in the out. Understand or not? It's very important now, because if you put the wrong direction, it will never work. Doesn't matter how good the rules are, it will never work. Right or not? Okay? Can that part? That side can. Okay? You guys okay? Now, do you have any questions here for this part? Come on, ask me question. David, do something, ask me something. So that my class can be 2 hours faster, ask me something. No question, ah? No question, very good, because I don't want to further explain. It may confuse you. But if you have further questions, then I'll explain a bit more on why. Now, maybe something that I can share to you in the previous class they asked. So now I say, in and out also correct. 0, 0 in, 0, 1 out correct. But is there a better one? Among 0, 0 and 0, 1? Is there a better one? If I put in 0, 0 in, will it be better or faster compared to if I put in FA01 out? You think got or not? Got a bit, very small. Because you see, if I put in FA00, okay, this is my data here. The data come here. If I put in 0, 0 in, here I check already as soon as I come in. Yes or no? If no, I throw away already. If I put in FA01, the data will go inside the router first. Then as it go out, only I check whether I want to throw away or allow. Understand or not? So if you put it here, it's kind of like a bit slightly faster. But a few milliseconds, you may not feel it. Okay? But there is slight difference. Okay? Now, the second thing I want to make this clear is, today I teach you how to choose this one. Because I draw like that, I always say PC0 send a data to PC2. PC1 send a data to PC2. That is why, if you use FA00, you must use in. If you use FA01, you must use out. This one everyone understand already, right? But why I cannot say the packet come from here? You see, now, this one, if you don't understand, it's okay. Here, you take a snapshot first. Remember what I just teach you. The next part is extra. If you cannot, you delete, roll back the update, okay? Later, you confuse more. Okay, now you see, here, I have a data here. Okay, I use this data. I always say come from here, but data is always two-way one. If PC0 or PC1 sends something to PC2, right? PC2 will definitely reply one. So the data will still somehow go in this direction. Then why I cannot say this one is in, this one is out? Why cannot? Because the data is like that, you see, come from PC2, go in, and then go out from here. Correct one, why cannot? It cannot one, because again, like I say, your ACL only work when they check the source IP. So you must see. I give you one example here. Let's look at this one here. If I send the data from PC1 to PC2, see, this is PC1. So the IP address of PC1 is 192.168.1.1. Right or not? I send to PC2. So the destination is the IP of PC2, which is 168.2.2. So here, 192.168.2.2. Now, if PC2 reply to PC1, the source IP is 192.168.2.2. The IP of PC2, right? Where I reply to? I reply to PC1. So PC1 is 192.168.1.1. Okay, now you see this packet. This one, let's look at this one. Okay, this is PC1 sent to PC2. So when I have this data here, it comes to the router, right? So it comes to the router. It will go in here. So that's why I say this is in, and then it go out from here. Now, as we check here, in or out, doesn't matter. This is the content. So you can imagine that this is kind of like the content of the data, right? So he will check whether are you coming from 1.1 or are you not. Like for example, our ACL here, you see, we will allow you if you are 1.1. That's why we have to do it this way. Because they will only check the source IP. I will not check this thing. Right? No? I don't care one, I don't check one. Okay, so far this part understand? That's why we must always follow this flow. Now imagine the other way around. Okay, now look at this. Look at this one. If I have a packet reply from PEC2, okay, you see, this one come here, and then come here, right? Now in this case, if I put the other way like this in, and then this out, okay, you see, the packet come here. So when it come in, I should check, right? Not because I put in, so when the data come inside, I must check. See, this is the data content. This is the content. If you actually look, it's like that. So the standard ACL always check based on what? Based on source IP. Now he will check, are you from 2.2? Right? Not. But you see your command, is there any 2.2 here? No. So it can never check because when we write the command, we only write, are you 1.1 or 1.10? Understand or not? So if you do it in the other direction, actually he don't know what you want to do because you didn't tell me what to do. Understand or not? That is why you cannot use the other direction. When you see which interface you want to put, which direction, you must always use the guide that you configure in the rule and then you do it this direction. Like that is correct. Like that is not. If you do like that, it's not. This is correct, because the way we design the rule, there is no 2.2 here. Understand? And also because the router only care about this one. Understand? If you cannot understand, also never mind because it's time for a break. I see you back in 10 minutes.